Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about rational functions. So a function written in this form, f of x equals p of x over q of x, is called a rational function where both p and q are polynomials and q of x is not equal to 0. And then the domain of this rational function are all x values, are all inputs, such that q of x is not equal to 0. And we already discussed about finding the domain of rational function in one of the previous videos. So a rational function could have a vertical asymptote at x equals a if when x approaches a, the function grows or increases without bound, or the function decreases without bound, which means, so for example, we have, let's say, a here. So when x approaches a, if the function goes to infinity or increases without bound, or it could be when x approaches a, the function goes to negative infinity. So in either cases, we'll have a vertical asymptote here, which is the line x equals a. Similarly, when x approaches infinity, if the function approaches to a horizontal line, let's say y equals b, then this line y equals b is called the horizontal asymptote of this function, okay? And then also it could be on the other direction, so the function could go to so when x approaches negative infinity, the function is approaching to a line, then this line y equals b is called a horizontal asymptote. Now, if there's no horizontal asymptote, then we'll have a slant asymptote, which is not a horizontal or vertical line. It could be a line which is at some angle with the x-axis. Now, how to determine the vertical and horizontal asymptote? So, to determine the vertical asymptote, we'll find the zeros of the denominator. So, the lines of the form x equals a are the vertical asymptote if a is the zero of the denominator but not the zero of the numerator. Okay, it has to be the zero of the denominator but not the zero of the numerator, which means if we have some common factors, okay, if we have some common factors in numerator and denominator, then we don't consider that factor for the vertical asymptote. In that case, we'll have a hole in the graph. We won't have a asymptote, okay? Now, to find the horizontal asymptote, we have three cases. The first one is if the degree of the numerator is less than the degree of the denominator. So for example, here, if this n is less than m, then the horizontal asymptote is the line y equals 0, or the x-axis. Now, if the degree of the numerator is same as the degree of the denominator, or m equals n, then the horizontal asymptote is the ratio of the leading coefficient of the numerator and the leading coefficient of the denominator. So y equals a sub n over b sub m. This should be m, okay? So that ratio gives us the horizontal asymptote. Now, the third case is if the degree of the numerator is greater than the degree of the denominator, then we don't have a horizontal asymptote. In that case, we'll have a slant or oblique asymptote. Let's look at an example. So first, we are going to find x-intercept, y-intercept, all the asymptotes, and we'll graph this function. So in order to find the x-intercept, we will set y, or the function, equals to 0. So if we do that here, we get 0 equals x plus 2 over x squared minus x minus 2. And then if we multiply by x squared minus x minus 2 on both sides, we get x plus 2 equals 0. That gives us x equals negative 2. That means the x-intercept for this function is negative 2, 0. Now let's go ahead and find the y-intercept. To find the y-intercept, we set x equals to 0. So we do f of 0 equals 0 plus 2 over 0 squared minus 0 minus 2. And that gives us f of 0 equals, we get 2 over negative 2, which is negative 1. That means the y-intercept of this function is 0, negative 1. The next thing is we are going to find the asymptote. So in order to find the vertical asymptote, what we do first is we'll go ahead and factor both numerator and denominator. So let's rewrite that function. So f of x equals, we have x plus 2 divided by, so the factors of denominator, which is x squared minus x minus 2, the factors are x minus 2 times x plus 2. So we don't have a common factor here in the numerator and denominator. That means we have vertical asymptote at the 0 of this factor and the 0 of this factor. Okay, so there are two vertical asymptotes. So in order to find the vertical asymptote, we'll set this equals to 0 and find the 0. So we have to do x minus 2 times x plus 1 equals 0. Now when we solve this equation, we get x equals 2 and x equals -1. That means the vertical asymptotes are x equals 2 and x equals -1. Now to find the horizontal asymptote, we just compare the degrees of the numerator and denominator. So the degree of the numerator is 1, degree of the denominator is 2. That means degree of numerator is less than the degree of denominator. That means the horizontal asymptote for this function is y equals 0, or it is the x-axis. Now let's go ahead and graph this function. So first we are going to go ahead and put our graph our asymptotes. So we have the vertical asymptote of x equals 2 and x equals -1. So let's go ahead and do that. So x equals 2 is this vertical line right here going through x equals 2. So this is x equals 2. And then we have x equals -1, which is this line right here. This is x equals -1. And then we have a horizontal asymptote of y equals 0, or the x-axis, so it's this one. We usually use the dotted line or the broken line to label the asymptotes, okay? Now the next thing we are going to do is let's go ahead and put our x and y intercept. So the x-intercept is -2, which is right here. And the y-intercept is -1, which is right here. Now let's start from the left side of the vertical asymptote, that is x equals -1. So what happens to the function, the graph on this part of the graph? Okay, so let's go ahead and figure that out. So in order to figure that out, we know that our x-intercept is -2, so the graph passes through this one, but we don't know whether the graph goes above x-axis or below x-axis here. Okay, so what we do is we will take a number between -2 and 1. We'll take a number here and check whether the graph is above the x-axis or below the x-axis. So for that, we'll just take f of -1.5 and put it in our function. So if we put it over here, let's use this one, okay? So -1.5 plus 2 is 0.5 divided by x minus 2, means -1.5 minus 2 is -3, times -1.5 plus 1 is -0.5. So what we are getting here is we are getting positive in the numerator and then also positive in the denominator. That means the function is above the x-axis. So here the function goes this way. And one important thing that we need to note is the graph never touches the vertical asymptote. It can cross the horizontal asymptote, but the graph never touches the vertical asymptote. Now from here, the graph, so we can take -3 and check whether again if it's above or below the x-axis. Okay, so if we do f of -3, then we get, if you put it in the numerator, we get -1 divided by, in the denominator, so -3 minus 2 is -5 times -3 plus 1 is -2. So we get negative in the numerator and then positive in the denominator. That means the graph is below the x-axis, so it goes below the x-axis, and then again it goes closer and closer to x-axis because that is the horizontal asymptote. Now what happens to the graph in between these two values? We know that the y-intercept is here, so the graph passes through this point. Now it cannot cross x-axis because there is no x-intercept. So that means we can easily figure out that the graph goes like this. Now to check on the right of that line x equals 2, let's pick this number 3 and let's plug it into our function and see whether the graph is above or below the x-axis. So f of 3 equals, when we plug it in there, we get 5 divided by 3 minus 2 is 1, 3 plus 1 is 4, times 1 is 4. So this is 5 over 4, which is positive number. That means the graph is above the x-axis. So it goes like this. So that's how we graph a rational function. Let's look at another example. Here, let's go ahead and find the x and y intercept. So again, to find the x-intercept, we set the function equals to 0, and then we multiply by the denominator. So basically, what we are going to get is we are going to get x squared minus 1 equals 0. And then if we solve for x, we get x equals positive or negative 1. That means the x-intercepts are negative 1 comma 0, and then 1 comma 0. Now for y-intercept, what we do is we put x equals 0, so we find f of 0, that gives us the y-intercept. So we get negative 1 divided by negative 6, which is 1/6. So the y-intercept for this function is 0, 1/6. Now, in order to find the asymptote, what we do is we will go ahead and factor both numerator and denominator. So we have f of x equals x squared minus 1 can be factored as x plus 1 times x minus 1. And the denominator is x squared plus x minus 6. So we can factor this as x plus 3 and x minus 2. Again, here we don't have the common factors. So that means the 0 of both the factors in the denominator will give us the vertical asymptote. So we are going to do x plus 3 times x minus 2 equals 0. And from here we get x equals negative 3. And from here we get x equals 2. That means the vertical asymptotes are x equals negative 3 and x equals 2. Now to find the horizontal asymptote, we'll look at the degree of the numerator and denominator. So degree of the numerator is 2, degree of the denominator is 2. That means the degrees are same. So the horizontal asymptote of this function is y equals the leading coefficient of the numerator, which is 1, divided by leading coefficient of the denominator, which is also 1. So that means y equals 1 is the horizontal asymptote. Now, in order to graph this function, again, we are going to do the same thing. So what we will do is we'll first graph the asymptotes. So we have the vertical asymptote at x equals negative 3. So right here, which is x equals negative 3. Then we have an asymptote at x equals 2 right here. Another vertical asymptote, which is x equals 2. Then we have a horizontal asymptote of y equals 1, which is this line right here, y equals 1. And then let's go ahead and put our x and y intercept. The x-intercepts are negative 1 and 1. The y-intercept is 1/6, so which is somewhere here. Now, it's very clear that for the middle portion, the graph should go this way. Sorry, it doesn't look nice, but yeah. For that, we can take this number, we can take negative 2 and plug it in. We should get a negative. If we take something from here, 1.5, and plug it into our function, we'll get a negative number. So that way we know that both part of the function are below the x-axis. Okay, so that's how it's going to look like. Now to figure out what happens to the function over here, we'll take a number from here. Let's take negative 4 and put it in our function. So f of negative 4 equals, so if we put it over here, so negative 4 plus 1 is negative 3, and then negative 4 minus 1 is negative 5, so the numerator is 15, divided by negative 4 plus 3 is negative 1, and then negative 4 minus 2 is negative 2. So then we get this as, so if we put here, okay, so negative 4 plus 3 is negative 1, and then we have negative 4 minus 2, which is negative 6, and then we get 6 here. Okay, so that means 15 over 6 is a number greater than 2, I mean greater than 1. So it is the graph is above that horizontal asymptote, so the graph should look something like this. Okay. Now similarly, let's take 3 and plug it into our function. So if we do f of 3, we get 3 plus 1, which is 4, times 3 minus 1, which is 2, divided by 3 plus 3, which is 9, and then 3 minus 2, which is 1. We get 8 over 9 here, um, which means the function is still above the x-axis. So right here. Okay, so that's how the graph of this function looks like. Let's look at one more example here. Again, to find x-intercept, we just take the numerator and we set it equal to 0. So x squared equals 0. We get x equals 0. So the x-intercept is 0, 0. Now to find the y-intercept, we find f of 0, which is 0 over 0 plus 2, and that gives us 0. So both x and y-intercept, they are the point at the origin, so 0 over 0, 0, 0. Now to find the vertical asymptote, we'll take the denominator and set it equal to 0. There's no common factor. We clearly see that. So x plus 2 equals 0. And that gives us x equals negative 2. So that is the vertical asymptote, which is x equals negative 2. And then um, what we get here for the horizontal asymptote is the degree of the numerator is greater than the degree of the denominator. That means there is no horizontal asymptote. So in this case, we'll have a slant asymptote or oblique asymptote, okay? Slant asymptote. So to find slant asymptote, what we do is we'll divide the numerator by denominator. We'll just perform the long division. So let's go ahead and do that. So x plus 2. So when we divide the numerator by denominator, what we get? So we get x here, x squared plus 2x, and then when we subtract, we get negative 2x. That means we have to put minus 2 here. So negative 2x minus 4. When we add them, we get positive 4 here. So this one, that gives us this slant asymptote. So the slant asymptote is the line y equals x minus 2. Now, in order to graph, again, we do the same thing. We'll graph the vertical asymptote and the slant asymptote. So the vertical asymptote is at x equals negative 2. So let's go ahead and put that here. So x equals negative 2 is a vertical line right here. This is x equals negative 2. And then we have the slant asymptote, which is y equals x minus 2. So the y-intercept of this line is negative 2, so it's right here. And then the x-intercept of this line is positive 2, which is right here. So this line is a line going through these 2 points, which is the slant asymptote for this function. Okay. Now let's go ahead and put the x and y-intercept. The x and y-intercept are just 0 and 0. Now in order to figure out where does the function go here, so let's take this number here, negative 1, and let's put it into our function. Okay, so I'm going to do that over here. So if I find f of negative 1, then I get negative 1 squared is 1 over negative 1 plus 2 is 1. So I get 1. That means it is above the x-axis. So the graph goes this way. Okay, and then it comes to the x-intercept, and then let's see if we take 1, what happens? So f of 1 equals, we get 1 over 3. That means it's above the x-axis. So from here it goes this way, and it goes close to that slant asymptote. Now similarly, what happens to the function on the left of negative 2? Let's go ahead and take a number, let's say negative 3. Let's take a number here. Okay, let's do f of negative 3, or we can do f of negative 4 as well. Let's do f of negative 4. F of negative 4 equals negative 4 squared is 16 divided by negative 4 plus 2 is negative 2, and that gives us negative 8. So when x is negative 4, the y value, the function is negative 8. So it looks like the function comes this way and then, sorry, it goes through that point and goes down. So the green curve represents our function. So we have the vertical asymptote and then we have the slant asymptote. Let's do this much for this video. I'll see you again in the next video.